Guys, welcome back to TechDose, and in this video we will see find the number of ways to place people one problem, which is from Leetcode number 3025. Let's now read the problem statement. In this problem you are given a 2D array points of size n by 2 representing integer coordinates of some points on a 2D plane where point set I represents xi, yi pair. Count the number of pairs of points a, b where a is on the upper left side of b and there are no other points in the rectangle or line they make, including the border. We need to return the count of such rectangles that we can make. If you look at the first example, in this case, can you make any point as the top left corner and another point as the bottom right corner? It will not be possible, because if you try to make it with, let's say, 2, 2 as the upper left corner, top left, then you do not have anything to the bottom right, isn't it? So since there are no such valid pairs, therefore the count is equals to 0 in such case. Now if you look at the second example, the configuration of the points are given, in this case 2, 6, 4, 4 and 6, 2. So you can make one of these as the rectangles, and which is valid because there is no third point which is lying either on the border or inside the rectangle. Okay, so since there are no such points, so this will be one valid rectangle, you can say, count 1. Another one would be 4 with 6, 2, so this will also be valid, the second one. But if you try to consider this 2, 6 with the 6, 2, then 4, 4 is lying inside it, and therefore it will not be valid. Okay, as you can see in the third figure. Therefore, since there are two valid rectangles, therefore the answer is 2 for this example 2. If you look at the third example, then there are 3 points in this example. If you consider this 1, 3 as the top left corner, then you can make a rectangle with just 1, 1 lying on the same straight line, same vertical line. This is also considered as a valid rectangle, and in between this, if you consider this rectangle, then you do not have any other point on this line or inside this rectangle, and therefore it is valid. Now, can you make something like this? You cannot make it, because if you consider 1, 3 as the top left and 3, 1 as the bottom right, you have 1, 1 on the circumference, right? So that is why it is invalid. And can you make this as the top left corner? Yes, a horizontal line can get connected to 3, 1 in such a way that there are no other points on this line or inside this rectangle, and therefore we will say that it is also valid. Therefore the count here is 2. I hope the examples are clear and all the special cases have been clearly mentioned in the problem. If you look at the constraint, then the n value is maximum 50. That means even if you write an n cube algorithm, that is going to be 5 cube times of 10 to the power of 3, isn't it? So this is around 625 times of 10 to the power 3, or you can say 6.25 times of 10 to the power of 5. So this is well within your 10 to the power 8 limits, and therefore it is going to pass within your 1 second. But we will try to optimize this solution even beyond this n cube. So this can be considered as the brute force solution, but let's see how the brute force solution works. Let's say that we have a set of 6 points on the xy plane. Now what we can do is, in a simple solution, we can go one point after another and consider each of the point as point A. So what I'm trying to do is, I will be trying to assume a rectangle where A is always the top left corner and all the other points B against which I will be checking is the bottom right corner. So if I assume that this point here 2, 7 is A, then I will try to iterate for all the other points and try to consider them as B. So can I consider this point as B? Yes. How do I check if this point is actually valid or not? So I should make sure that the x coordinate here, that means the x coordinate of B, must be greater than equals to the x coordinate of A. That means the point either lies on the same vertical line or it must be on the right side. It cannot be on the left side. Okay. So whenever I consider A, I'm just trying to see something to the right and bottom, so that only this view can give me the bottom right corner. So bx must be greater than equals to ax, and also I must see that the y coordinate must be less than equals to the y coordinate of a. Why this should happen? This should happen because if you have a b here, definitely the y value decreases if you move down. You can see this y axis. If you move up, the value is increasing. If you move down, the value will decrease. So b must be either at the same level or it should be below a to make it a bottom right corner. Therefore the y coordinate by should be less than equals to ay. So these two conditions must hold true in order for a point to be considered as the bottom right corner. So can this point be considered as the bottom right corner b? Yes, it is valid, because if you see the x coordinate, 2 is greater than equals to 2 and 4 is actually less than equals to 7. So this is valid. Once you have done the validity check, then you know that you can make a rectangle out of it. But another condition is there any other point lying inside this rectangle that you make? In this case, it is just a vertical line. Is there any other point lying inside this or on the circumference? So in order to check that, you have to iterate for all the rest of the points except for a and b. You need to iterate for all of them. So if you iterate for 5, 6, you need to check if it is lying inside this rectangle. And how do you know that if you have a with some x1 comma y1 coordinate, and if you have b with some x2 comma y2 coordinate, how do you know that if a point lies inside this rectangle or not? Let's say a point here, x3 comma y3, is it lying inside? So the thing is, this x3 must be, you can say, greater than equals to x1 and less than equals to x2. This should be one condition. And another thing is y3 must be greater than equals to y2 but less than equals to y1. If these two conditions hold true, then the third point against which we are checking, let's say point C, will be lying either on the circumference or inside the rectangle. Okay, so once we have fixed a and b, and I have found that b is a valid bottom right corner using this condition, then I will have to check against another set of point, which is C. Okay, so I will have to iterate for all the rest of the points except for a and b and try to see if any of these points lie inside this given rectangle. Right, so yeah, I can just use this condition to check if the third point is lying inside the rectangle or on the circumference. If it does, then this rectangle where a is the top left and b is the bottom right cannot be counted as a valid one. But in this case, if you check with any of them, none of them will satisfy this given condition, and therefore this AB will be a valid rectangle, and that is why I will keep a counter count equals to 0, and as soon as I have checked with all the rest of the points and I could not find any conflict, then I will increment the counter to 1. And I will repeat this with the rest of the points, all the combinations. So next time I will try to pick this as B. So can this be picked as B? Yes. 2 is greater than equals to this 2, and this 2 is actually less than equals to 7. So this can be a valid bottom right corner. Now I will be checking against all the points. If you check against this 2, 4, you will see that it is satisfying this condition. Therefore, this B that is picked is actually not valid, because another point 2, 4 is lying on the circumference or inside the rectangle, and therefore we will not be counting it. Now we will move to the next point 5, 6 and consider this as B, because it satisfies the condition for B to be the bottom right corner, and I will check against the rest of the points and I will see if they are lying inside the rectangle or on the circumference. We will not be finding anyone, and therefore this will also contribute one value. Okay, so if you keep checking like this, then for this point we will have 2 contribution. Now for this point, how many contributions do I get? 1 contribution and then 2 contribution. Okay, 2 contribution, and this can also be another contribution. So it will be giving me 3 contribution of rectangles. This will not be giving me any contribution because this is the top left corner. Can this give me any contribution? This is 1 contribution and this is another contribution. So 2 contribution will be for 5, 6, and for this 5, 3 we do not have any contribution, because I am thinking that each of these points has the top left corner like A, and this 7, 4 will also not give any contribution because you don't have anything to the right and and below it. So the total contribution will be 2 plus 2 4 plus 3 7, and therefore the count will be 7 at the end. If you follow this approach, then we have to use 3 loops. The first loop will be for each A. I have to try for each B, and once you have picked all possible combinations of A and B, which is n square combinations, then for each of them I have to try with C by iterating through the rest of the points, which will be giving you another n factor. So the time complexity for the brute force approach is going to be n cube, and the space complexity is just O1, because we are just taking a single variable, a counter. Okay, and I know that this brute force approach is going to pass, but let's try to see an optimization over this idea. Now if you think about our brute force approach, what was happening? We were actually taking A because it was considered to be the top left corner in the rectangle to be assumed, and B as the bottom right corner. So creating all the combinations was taking you order of n square, right? But in order to optimize, what we can do is, generally we have to check for all possible combination. We cannot avoid that. And if I have to check this, then how to check if there is another point which lies in the circumference or inside the rectangle bounded by A and B? Well, I can actually optimize it. In order to optimize, if I can just order all the items, then I will know that if there is anything in between A and B, I can find it optimally in just O1 time. Well, in order to understand this, let's first see the solution and then we will understand the idea behind it. We will be arranging all the points according to the x-axis, right? So we will be sorting all the points on the x-axis, so that whenever I see a point A1 and after that I see a point A2, then I'm guaranteed that A1's x coordinate is less than equals to A2's x coordinate. Okay, so either A1's x coordinate is less than A2's x coordinate or they are same. So if 2 points have the same x coordinate, then what I will do is I will be checking for the y coordinate. So I will be arranging each of them in the decreasing y coordinate, so that A1's y coordinate will be less than equals to A2's y coordinate if and only if A1's x coordinate is equals to A2's x coordinate. If the x coordinate is same, then I will be sorting it on the y coordinate. Now why this is required? This is required because if you have a bunch of points, in this case 6 points, then I will be moving exactly top down order in the same x coordinate and left to right on the x coordinate. Because if I assume this as A, like if I assume this as A, then what will be the combinations of B? I will be ignoring all these 3 points on the left because they can never be the bottom right corner. So I will be not doing any kind of useless comparisons. First of all, if I arrange on the x-axis, then I know that if I have picked an A coordinate, then the B, which is the bottom right corner, must be to the right of A. Okay, either it is on the same x coordinate or to the right. So if I have sorted it based on the x-axis, then I know that everything I see next to this A will be either in the same x coordinate or to the right hand side. That is point number 1. That is why I need to sort it in ascending order of the x coordinate. And point number 2 is, why are we sorting it descending order on the y coordinate is, if you have, let's say, another point here. Okay, so which point should be considered as the next point to be the bottom right corner? It should be this point here, right? Which is 5, 4. This should be considered as the bottom right corner. We should not directly jump to 5, 3. Because if on the same x coordinate, if you have 2 consecutive points or many consecutive points, it will be impossible to have a valid rectangle skipping just the next point. It will be impossible. If you have a rectangle on the same x coordinate, it will always be for this 5, 6 and 5, 4. If you consider 5, 6 to be the top left corner, it can never be for any point below this 5, 4. It will never be the case because 5, 4 will lie on that line. Therefore, if I just sort it on the descending order of the y coordinate, then I know which is the next valid point. That is why the sorting on the y axis is important. So again, I am repeating that sorting on the x-axis is important, because if you have considered a point A which is the top left corner, then I know that if I move to the right hand side in the sorted order, then I will get a B which is either on the same vertical line or lying to the right hand side. So that is what I want to do. So this will be removing all the unnecessary combinations which I don't need to check actually, and sorting on the y-axis will make sure that whatever next point you are seeing is a valid candidate to be the bottom right corner. Okay, so these two things are important for our optimization, and let's say that you have understood this. Then how do we solve this problem? Now in order to solve this problem, let me show you with an example. So let's say that you have picked this as your a value. Okay, the 2,7 is your a value. If you consider anyone to be the v value, what we will do, we will be considering each of the point one by one. We will be considering this 2,4 as the b point. So this is just the next point, isn't it? This is just the next point in the same x coordinate. So can this be considered? Yes, it will always be possible. We don't even need to check for if this b is valid or not, because it is sorted on the x-axis and y-axis. So whatever I see after this assumption of a will always be valid. I don't need to check for the validity as I checked in the brute force method. Okay, now if this is already valid, then I just need to check if there is a third point in between, right? So for considering the third point, you already know what is the condition. If you have a point here and a b point here, I just need to check if there is a point c inside it. Since you are moving on the sorted order, and if you have assumed a, the c must have happened after a. That is the first condition. Therefore the x coordinate of this c will always be in between this a and b, because if you are starting a loop from a, and if you are maintaining the past scene items, and let's say the past scene item was c, c's x coordinate must be greater than equals to a's x coordinate. That is for sure. Okay, and if you are looking at b later than c, then you know that b's x coordinate will be greater than equals to c's x coordinate, that you can write. So do I need to check the x coordinate? I don't need to check it. I don't need to check it for any item seen between this a and b, because it will definitely be in between. But just maintaining the x coordinate of this c is not sufficient to say if this is overlapping, because this could have been here as well. Okay, so do I have the x coordinate in between a and b? Yes, but is this c overlapping? No, it is not overlapping, right? It is not overlapping. So what should I see next is its y coordinate should also be within this range. As I had explained in the brute force approach, the y coordinate should also be in the range. Okay, so if I have maintained the y coordinate seen for this value c here, then I will say that whatever is the y coordinate seen, let's say the cy, if it is somehow greater than equals to your y coordinate of b, if it is greater than equals to the y coordinate of b, then I will say that it will be overlapping, because the x coordinate will always be in the range. If the y coordinate somehow falls within the range, that means cy is greater than equals to by, then it will be overlapping. Now if you give me a counter argument that you have a c here, so how will it be overlapping, then I will not be saving this into my result even. I will not be maintaining this as the previous point. I will only be maintaining such previous points which can be used to make a valid rectangle with a. And if you have made a valid rectangle with a, then only this will be considered as the previous point. Okay, it may not be clear from this explanation, so let me show you a dry run which will make it absolutely clear. Now let's think about this being the a coordinate. Okay, now I will be iterating for all the b coordinates, and imagine that all the points are sorted on x-axis and decreasing order on the y-axis if x value is same. Now I'll be considering this as b. I will have the counter value set to 0, and you can say that for each of this a value I will be maintaining the previous y index. So let's say the previous y index will be maintained, and this is minus infinity. Okay, now if I check for this b, it will always be valid, as I said, because it is sorted. Now I just have to check if I have seen a previous item which lies between this A and B, which can actually create an overlap. So we need to check the y coordinate only. This previous saying minus infinity is, it is not lying in between this A and B range. Okay, the y coordinate range here is 4 to 7. If it was lying from 4 to 7 anywhere, then it will create an overlap. Then this will become invalid. But here it is not invalid, and therefore it will contribute to one count, and I will be incrementing the counter, and I will say that the previous point which was valid is at y coordinate 4, so I will be saving 4 here. Now when I go to the next B point, when I try this 2, then I will say that it is valid, but I need to check with the previous point. The previous point y coordinate being 4, which is lying between this 2 and 7, makes it invalid, and therefore I cannot include this in the valid set of rectangle where 2, 7 is the top left. Okay, so this will be skipped. If you consider this 5, 6, then you need to check, can this be a new B point? So this will be valid bottom right corner, but you need to check with the previous y coordinate. It is 4, so it is not lying between this 6 and 7. So if you create a rectangle here, then there will be no overlap. So yes, it is valid. So increment the counter and also save the new previous point to 6. Now if you consider this 5, 3, it will be invalid, because the previous point here 6 is lying between this 3 and 7. So it is going to create an overlap here, you see, right? So it will not be counted. If you consider this 7, 4, for the same reason it will not be counted, because the previous y coordinate, previous valid y coordinate that we have picked, 6, is lying between this 4 and 7. So there will be only two contribution coming from this 2, 7. This is one contribution and this is another contribution. Now whatever I will do, I will be iterating for the next A value, which is this 2, 4, and I will repeat the same process, and the previous will again be reinitialized to minus infinity. So I will do the same thing. Next point is 2, 2, and you will see this is minus infinity, not lying in the range from 2 to 4. So this is going to be valid. Increment the counter to 3 and save the previous coordinate to 2. Okay. Now with this 5, 6, this will not be considered, because if you see the y coordinate here, 6 is actually greater than this 4. So it cannot be considered as the bottom right corner. If you see this 5, 3, yes, it can be the bottom right corner, and the previous 2 is not lying in the range of 3 to 4. So this is valid. Okay, so I'll be incrementing the count. Previous will be updated to 3. If you check this 7, 4, then yes, it can be considered, because the y coordinate is same. Okay, the bottom right corner's y coordinate should be less than equals to A. So yes, it can be considered. And if you look at the previous y coordinate, is it lying between 4 and 4? No. So this is valid. Increment the count to 5 and set the previous to 4. Now we are done with all these combinations. Let's take A here. And if you take A as the third point, there will be no valid B, because all the y's are larger. If you take the next A value, which is 5, 6, you will find that the next point is 5, 3. The previous will be set to minus infinity definitely. And if you consider this as B, then in between this 3 and 6, there is no previous point, and therefore it will be valid. Increment the counter, the previous value will be set to 3. Again you check for this B, right? So is this valid? In between this 4 and 6, there is the previous is not lying. Okay, so I will be incrementing the count to 7 and the previous will be set to 4. Again, when you are done with all the A combinations here, try with 5, 3. Now if you try with 5, 3, everything to the right is above this point 3, and therefore there will be no valid combination, and for the last point you don't even need to try. So when you have tried everything up, then the total count was 7, and therefore the answer is going to be 7. So in this particular case, if you have n number of points, then the sorting step will take n log n time. And after this, in order to generate all possible combinations of A and B, it will take n square time. And for each of the pair, we were just maintaining the previously included point, so that we have to check if it is creating any kind of overlap. And if it is not creating any overlap, then we will be counting it, otherwise we will not count it. So this check will be done in O1 time, and so the total time complexity is going to be order of n square, and the space complexity is order of 1 because we are not taking any extra space. I hope it is clear. Let's now look at the code. If you are someone who is looking to prepare for top product based company within a limited time of just 3 months, then we have brought for you both the DSA and the system design live interview training program. The most important feature of this program is you get a filtered and condensed structured curriculum, in-depth discussion of all the topics, and my guarantee of your understanding, one-on-one guidance with me, and live weekend classes. To know more about the training, you can WhatsApp us on this given number. In this problem, we are given the points, and the first thing we will be doing is sorting based on the x-axis, and if the x points are same, then we will be sorting in descending order of the y coordinate. So this is a custom comparator that I have written, and after this we'll be maintaining the counter starting with 0 and try all possible combinations of a and b. When you have taken an a point, then I will be taking the bottom right y, which is your previous point, and after maintaining this, iterate for all the b coordinates and check that the b point is actually lying to the bottom right corner, and if it does, then we need to also check that the previous point is not lying in between this rectangle, okay, somewhere in between the rectangle overlapping. So if there is no overlap, and if the bottom right corner is actually lying below this y coordinate of a, then it is valid. So we will be incrementing the counter, and the bottom right corner's y coordinate will get updated. Okay, so after counting all the valid pairs, we will be returning it as a result. I hope it is clear. If you still have any doubt, then feel free to comment below and I'll try to help you as soon as possible. If you have any other idea, please comment down below and we will be happy to review that as well. See you guys in the next video. Thank you.